Assalamualaikum warahmatullahi wabarakatuh. A very good morning to all my team members, our beloved lecturers, Dr. Izam bin Abdul Karim. My name is Nur Syatul Amira binti Muhammad Sharif. My metric number is 188203. I am from Group 11. Today, we would like to present our mini project, which is analysis of three-story building. As you can see here, this is our presentation outline, which is divided into by 8 sections. First is the introductions, followed by problem statement, assumptions, methodology, results, limitations, recommendations, and lastly is the conclusion.
In this project, the client requested to report an extensive analysis of the building under your request provision of several subframe analysis, and the client also requested a reinforced concrete building. Reinforced concrete is an important part of the structure. It's widely used because they have high fire and weather resistance. They absorb the tensile, shear, and sometimes the compressive strength in a concrete structure. They also have a very low maintenance cost. Structure analysis is also very essential because it establishes a foundation for structure design and determines whether a particle structure can withstand external and internal loads and forces. It also helps us to determine the cause of structure failure. The three-story building and its roof was designed using static loads given and analyzed in both 2D and 3D. So the main objective of this project is to propose a truss system of the pitch roof with a max height of the roof to be between 6 meters to 7.5 meters. We also need to analyze the full building in 2D and 3D using structure analysis software and manual calculation. We also need to design the subframe of the full three-story building by using the parameters that have been given. Also, we need to compare the values of manual calculation and software analysis, then justify. And finally, we need to discuss the consequences of the modeling, approach, or assumption.
As an engineer, structural analysis is very important in construction work to analyze the load reaction and effect of the load on the structure. So in this project, we need to determine the UDL from slab to beam. And then we need to analyze the 2D and 3D structure using LinPro and SAP 2000. And then we calculate all the reactions manually. And lastly, we determine the difference value obtained between the manual calculation and software calculation. This is to identify which method is the best method to analyze the structure.
For this project, there are a few assumptions that are being considered. First, all spans are loaded, which is dead load and live load. Okay, for the subframe, we assume that the size of beam has the thickness of beam is 0.6 and the width is 0.3 meter. And for the slab thickness is 0.35 meter. For the truss, we assume that the number of trusses is 7 and the truss span is 3.5 meter.
As is for the methodology, there are two types of methodology needed in this project, which are the roof analysis and also subframe analysis. For roof analysis, the first step is to determine the design and also specification of the truss. For example, is the diameter and height of the truss. Next is to determine the UDL, which is the uniformly distributed load that is acting on the truss. For example, we have the self-weight of top chord and also the roof sheeting and insulation. Next is to determine the support reaction at A, B, and C and D, and also using the manual and also software analysis. Next is methodology for subframe analysis. For subframe analysis, the first step is to determine whether we have the one-way slab or two-way slab. From our project, we determine that our project is actually a two-way slab for each slab section. So for two-way slab, we have the trapezoid and triangular load. It means that we can analyze this frame in 2D and from two sides. For example, we have front view for maximum or minimum trapezoidal load and side view for minimum or maximum triangular load. So when we analyze all this, we can analyze it by using manual and software analysis. For manual calculation, we can use the moment distribution method and get the overall moment that is acting on each member and also column. For software analysis, just compare the value with the manual calculation, and after that we can get the percentage error, and yeah, that's all.
Okay, so this is our results of subframe analysis of maximum shear force in kilonewtons. As you can see here, we have two two structure, which is minimum trapezoidal front view, and secondly is a maximum trapezoidal front view. And this result we analyze by using manual calculations and appropriate software 2D, which is LimPro, and also 3D software as AP 2000s. Okay, next is a minimum triangular maximum shear, and lastly is a maximum triangular for maximum.
Next, this is the data for maximum and minimum trapezoidal load for maximum shear, and the data was not different from each other. And next is this is the minimum and maximum triangular load, and the shear force diagram was not different from each other.
So yeah, as you can see here, these are comparisons between manual calculations and software LimPro 2D and SAP 2000 3D. So for example, we took at a member AB for the minimum trapezoidal maximum shear and look at the percentage error for SAP 2000s. There are 0.034%, which is less than 1%. As you can see here, all of our percentage error is less than 1%. It shows that our manual calculations is near or almost same with our software analysis. Same goes with this structure. All of the percentage error is less than 1%, which is it shows that our manual calculations is almost same with the software analysis.
So here is the percentage error for minimum trapezoidal maximum bending. Okay, from here we can analyze that the percentage error for SAP 2000, the highest value is at member CD from the first floor, which is 0.147, and then for LimPro is at the member AB from the first floor, which value is 0.102. And also for the maximum trapezoidal maximum bending, for the percentage error using SAP 2000, the highest value is at member AB and CD from the second floor, which has the value 0.044. And for the percentage error for LimPro is at member AB from the first floor with the value 0.101. Here is the percentage error for minimum triangular maximum bending. Okay, for the percentage error for SAP 2000, the highest value is came from member AB and CD from the second floor, which has the value 0.064. For the percentage error for LimPro, the highest value is came from also member AB and CD from the second floor. For the maximum triangular maximum bending, for percentage error SAP 2000, the highest value is from member AB and CD from second floor, 0.017. And for the percentage errors LimPro, the highest value is from member AB and CD from first floor.
This is the examples of the subframe analysis by using 2D modeling using LimPro 2D. This is shear force diagram for the trapezoidal maximum front, and secondly is a structure for trapezoidal min front. So this is the subframe analysis by using 2D modeling using LimPro of bending moment diagram.
Here is the 3D model using SAP 2000s. So we analyze the structure by inserting all the value on the beam and also from the truss. So here is the deformed shape of subframe, and here the reaction that acting on the subframe.
I'm going to talk about the result part for the support reaction of truss system. So we have two truss, which is inner and outer. So when we see overall, the percentage of error we get for inner and outer is only fall between 0 to 2%. Besides that, the value we obtain for manual and software are in the same direction. And the errors we obtained earlier might be due to the decimal places in our manual calculation. But then, value we obtain from software is more accurate when we compare to the manual calculation. When we see the value between LimPro and SAP is almost very close. So it shows that software's calculation is more accurate when compared to the manual calculation.
This is the 2D model for our truss system that we drew using LimPro software. As you can see, on the top is our outer truss and on the bottom is our inner truss. And here's our shear force diagram for outer truss and inner truss. And here's our bending moment diagram for both outer truss and inner truss.
After analyzing the truss system using SAP 2000 software, this is the result that we get for the support reactions, on inner and outer truss. This is outer truss, truss 1 and 7. Inner truss is truss 2, 3, 4, 5, 6. The value that we obtain for the support reactions are almost accurate with the value obtained from LIMPRO software and manual calculation. From the result, the support reactions for inner truss are higher than outer truss because the load act on the inner truss are higher than the outer truss. And how I analyze the truss using SAP 2000 is I define the materials and frame sections of the truss, and then I insert the point load at each joint of the truss, and I run the analysis to get the reactions at the supports and also the deform shape of the truss system. So this is the deform shape of the truss that I get from the SAP 2000 analysis.
And I'm going to talk about the limitation that we have in our project. There are 7 limitations. The first one is calculation for the Zoom analysis and subframe. Next is difficult to deal with software. We have a minimum knowledge on how to use this. Third, value obtained from SAP 2000 and LIMPRO are different. The difference sometimes can be a small amount or large. Third is decimal points. Decimal points are important because this can affect our final value. Next is value of the manual and software are different. This causes us difficulty when we compare the values. Next is the software features. We are unable to run this analysis after we run the codes. And last is error in analysis, where when a wrong info is entered in software, therefore the entire thing goes wrong. Not only software or in manual calculation also.
Okay, so let's move on to recommendations. The first recommendation is all of the engineer and architects must have previous expertise design. And second is installing a large amount of natural light is more difficult, but it's the preferred finish for the most building. The third is SAP 2000 software also has a restriction such as some parameter not being available in manual calculation for 2D analysis using LIMPRO. The fourth is a specifics of the restrictions discovered while using the LIMPRO program. And lastly is maybe the next time in this report, we should contain a detailed cost estimate for the project.
Our primary goal of this project objective have been achieved. A 3-story building frame that functioned as a complex structure in real life have been analyzed. We also did this in response to the client request and in accordance with their specific requirement. That's all from us, Group 11. Thank you.